In this video, I will review the key terminology and structure associated with physics simulations. In 3DEXPERIENCE, we create a physics simulation when we use either computational fluid dynamics or finite element methods to examine the detailed physical response of a part or system. We will continue to use the load transfer device to guide our discussion. To perform a CFD or finite element analysis, we create a physics simulation object. This object contains model, scenario, and results data. We will cover these three items in more detail. The simulation model includes all of the items associated with the physical product, including 4 3D parts, each with a single 3D shape. A material is assigned to each of the parts. Underneath each 3D part, there is also an abstraction shape and finite element model. Finally, there is an assembly-level finite element model under the physical product. The other items like drawings and mechanism analysis are not relevant to performing CFD or finite element analysis. Let's examine the bolt 3D part in more detail to understand the key things required for performing a simulation. If you recall, we recommend assigning the material to each 3D part. For performing physics simulations, we also need to ensure that the material definition includes a simulation domain that specifies the relevant properties. For the material assigned to the bolt, we have specified the density, elastic modulus, and Poisson's ratio. The abstraction shape is an object containing the geometry used in our simulation. When we create an abstraction shape, 3DEXPERIENCE places a dependent copy of the design geometry into the abstraction shape. This allows us to modify the geometry for our simulation without affecting the design. For example, while the chamfer on the head of the bolt is important for the design, it may not be critical to include in our simulation. Using an abstraction shape, we can remove the chamfer without impacting our design intent. It is worth noting that, because it is a dependent copy, the abstraction shape geometry will automatically update whenever the design is modified. The final item associated with the simulation model is the finite element model. It includes the finite element mesh and the section definition. The section definition associates the material and a specific constitutive response with the mesh. It may also specify material orientation, shell thickness, or integration settings. To perform a simulation on the assembly, we use the finite element model that was inserted into the physical product. In this assembly-level finite element model, we select the part abstractions that we want to include in the simulation. Notice, we can select both 3D shapes and abstraction shapes. We recommend selecting only abstraction shapes. We also select the specific part-level finite element models to include in the simulation. To define the scenario, we simply activate the finite element model, click on the compass, and select one of the scenario creation apps. This creates a new tab containing a new physics simulation. The scenario includes contact interactions, restraints, loads, and output requests. It also includes step definitions. The results include all data specified by the output requests in the scenario. Simulation results may either be stored on the platform server, or on the local computer. By default, simulation results are stored on the server. However, these results may require significant storage space, and academic accounts typically have limited storage capacity on the server. Therefore, we recommend storing simulation results on the local computer. Please note, model and scenario data is always stored on the server. At some point, you will need to find related 3D parts, physical products, and physics simulations. Locating the 3D part or physical product associated with a specific physics simulation is straightforward. With the physics simulation open, you simply right-click on the 3D part or physical product and select Open. Locating the physics simulations associated with a 3D part or physical product requires a bit more effort. We need to search for the 3D part or physical product. Then, right-click on that object in the search results and select Relations. This launches a new window with the selected part or product and an expandable map showing all data related to it. You can see that there are 3 simulations associated with this product. After locating the simulation that I want, I can right-click and open it.